Okay, so this is really good because you've heard a lot of facts, lots of information today, and we're going to talk about memory, which was already discussed, which is pretty nice. I'm going to make it short. This is the end of the evening, and hopefully you will find it educational. This is a little bit about my journey starting to use OpenClaw as an agent and actually using agent in general. We're talking about memory. We're talking about relationship. We're talking about Atlas. We're talking about all kinds of stuff that relates to that. But basically, the challenge is how will I make my agent a little bit more robust and be able to remember stuff. So, what is the challenge? Let's talk about the problem. Most of the agent, when you start to work with them, whether it's Copilot, Cloud Code, OpenClaw, whatever it is, doesn't really have memory. So the context window is very small. It has a short-term memory. Once you close the session, the memory is gone, right? So you need a way to persist it. One of the things people are doing is they use MD file and all kind of this type of solution. So the second thing is even if you do use memory, you don't really get a personalized experience, right? So it means that it stores things in a very generic way. And when you talk to your agent along, a few months, you're not necessarily going to get the information. So how do you solve that? One, you want to use we want to move from a goldfish to an elephant, which means that you want to move from short-term memory to long-term memory that is very persistent. The way to do it is to have something that's more persistent, that we're able to work across multiple sessions. You want to be able to have personalized experience, which means I'm asking questions, I'm getting answers in the context that I'm asking them, and everything needs to be consistent. This, by the way, works really well. So we're here, FalkorDB and Neo4j. So I'm talking about graph. Just in case, no, it's not clear. I'm Guy, and FalkorDB is a graph, label property graph like Neo. We prefer it on triplet. So the way we present the value of the graph as a context memory is using the iceberg metaphor. Why? Because the first thing that you think about it, the first challenge, and I'm not going to go into why vector database is good or bad. That's not the discussion here. Everyone knows that vector database has a bit of limitation when it comes to persistent data and having a relationship. So the first thing when you work with graph database is it has relationship. So when I need to access data, it actually knows the context, right? I'm working in this company. I'm living in this city. This is all edges that exist within my data. But the second thing is I want to be very flexible on how I attach memory to agents. What does it mean? It means that, I'm running, and you will see it, I'm actually running two agents, which I want completely separated. So I want complete isolation between those two agents. I don't want to put the data on the same file. But I may also want to have 1,000 agents that have exactly the same context, right? And that context will evolve. All of us are probably, and I want to open my Copilot because it's pretty messy, are using agent for months. So the more data, the more you talk to your agent, the more context you give it, the more information you give it, the more you want it to be intelligent and context evolve. And that means that you want to use that context, even if you add that data 2 months ago, to be able to retrieve it in a very intelligent way. The last piece, and again, this is more comparing to very naive file system for context, is you want to be able to patch your memory. You want to be able to upgrade. You want to be able to have browser. You want to be able to have those capabilities. This is my setup. This is actually, so I'm going to show you a demo. Hopefully this is actually going to be a realistic example on my experience, and I will explain the story in a second. But what I did is I took a Ubuntu, very small one in my house. I installed OpenClaw. I put Cognee. I didn't actually talk about it so far, but Cognee is a really good memory plane application that connects the agent to the graph database. I'm not going to talk about ontology. It sounds simple, but actually it's very complicated because you need to be able to correct the right data, and it's not that simple. At the end of the day, creating an ontology, automatic ontology is a challenge. Cognee is doing a good job, and it has direct skills that will connect OpenClaw into FalkorDB. and I'm using Telegram to communicate with my agents. This is my two agents, Will and Elizabeth. So you probably want to set up a machine where you have multiple agents that do multiple things that are completely detached from each other. So Will is the agent that I use when I go to event like this. So if I'm going to talk to you, I'm going to ask you what's your name, where you work at, what city, and stuff like that. And I'm actually going to open my Telegram and I'm going to write to Will, I met Trudy at AWS Build event for Data Strater at this date, and she's working in that company. And is going to actually store that data in them. So let's see the demo. What you're seeing right now is I used it first in a real thing, and then I said, let's just record it and show it to everyone. So you see here my two agents, Will and Elizabeth. As I said, they're real agent, and the way I communicate them is through Telegram. And what you basically, I'm going to move it fast because it's a pretty long video, but what you're going to see right now is me providing input to my agents and how the data is being stored in FalkorDB. This is FalkorDB browser. So this is the way to view the data. As you can see, I have two graphs here. So I wanted to make sure I have a complete separation between the memory of Will and the memory of Elizabeth. And this is at how the data is stored. So each one of them is its own memory space. How many of you are familiar with Cypher? Not surprising, the Neo4j guys. So Cypher is a way to just query. It's like SQL for graph database. That's the way to query the database. And what I'm going to do right now is I'm going to check whether the graph has any knowledge of the entity called Tokyo. So whether it's aware of any data. But by the way, this is another really nice thing when you work with a graph to connect your agent. You can very easily access that graph and check what data exists in that graph. So it makes it pretty easy, compared to vector database or just a text file, because then it's not deterministic data. So in this case, what I've done is I've checked if I have any data about Tokyo in my graph, and there wasn't. I don't know if you noticed that. And what I'm going to do is I'm going to pass it quickly. I'm basically inputting data within Telegram to Will, and I'm telling them which people I'm meeting at the show. This is, as I said, this is what's happened. I prepared the script. So I met two companies. I met Edometrics. It's a DevOps company headquartered in Tokyo, Japan, founded at this time. Each one of the details here is going to create an edge. So it's really going to be meaningful. It's just both pieces of data with a specific relationship between them. And now I'm going to add the second company, and I'm just going to move it a little bit faster. You will need to trust me that I'm inputting more and more people into Telegram and multiple companies. And Will is saying, great, I got this information. I was very happy about it. And we're back looking at my memory. So by the way, it's kind of nice. It's really nice to talk to your agent and actually go and see the notes that are being created on the fly, including myself, including the people I work with. But now I'm running the Cypher that checks the existence of Tokyo. And you can see here, I see Japan as a node, Tokyo, the company Edometrics, and all the information that I update Will through the Telegram. The second thing I can do is I can say, okay, great. Now I know which companies are in Tokyo. Now I want to see who works in those companies. So I'm going to go back to the query. And I'm going to say, I want to look for people that work in a company in Tokyo. It's very simplistic. And again, this is very real. But if you think about it, if you ask any other context, I want to know about people that are in Tokyo, you may get a very generic answer, not specific to you. And that's the big difference. You can see it here. You see this company is headquartered in this place, and et cetera, et cetera. Cool. I'm not going to bore you more with demos. Let's just quickly finish. So this is my stack, just a nice AI created architecture of Will and Elizabeth. This actual setup is not correct anymore. Cognee now have a skill that allow you to create and set up memory per agent. So you can create as many agents you want, and you can decide which graph it will go to. one of the unique things I do have to say, actually, one more thing. I'm not going to talk about it too much, but one of the things that people don't talk, and you probably saw that with your agent, is I'm out of context. I need to define the context. I need to reload the context. I need to compact the context. I need to do this. I need to do that. How expensive it will be. This is how much money it costs me to work as a graph database with my agents, which is the pennies and dollars to do all this work and communicate with them all the time. So this is very token efficient. And I'm going to jump and just going to say a few words about FalkorDB specifically. It's very easy to create 10,000 graphs in FalkorDB. We have built-in configurations. So you can what I showed you right now is basically a single instance of Falkor with 2 graphs. You can create 500 graphs, 1,000 graphs, as many as you want. It has a very easy scaling, and I didn't mention that before, it's based on Redis. So it's in memory and it's super fast. That's it. Thank you.
Any questions for Guy?
What does based on Redis mean? Can you elaborate on that?
Yeah. Redis, I've been working in FalkorDB since the beginning of the year. I worked at Redis for 11 years. Redis used to have modules, Redis modules. I don't know if you heard about them, Redis Search, Redis AI, time series, etc. Redis Graph was one of the modules that was created. And 3 years ago, Redis and Graph and Redis disconnected as a company and FalkorDB was created. So we're still based on Redis, but it's a complete model. So it's not dependent on Redis but it's running on Redis. It's in memory.
Any other questions? Cool. All right. Thanks, Guy. And thanks everyone for engaging in this.
Thank you.